Hi, I'm Amanda from Amanda's Reading Corner. I'm so excited you're joining me today. We're going to be looking at 3 great books, all about space. Are you ready to explore with me? Let's go let our minds take flight. The first book we're going to look at today is all about the solar system. Let's find out what fascinating facts are in this book. Before we start reading today, we're going to go to the back of the book first. We're going to go to page 30. This page is called a glossary. Here's some of the words in this book you may not know. This page tells you what they mean. A planet is a huge mass of rock or gas in space that moves around the sun. An asteroid is a lump of rock that moves around the sun. Orbit is the path of something as it goes around something else. A crater is a round hole on a planet or a moon made by a rock crashing into it. A rover is a computer-controlled vehicle that drives across the planet. A probe is a computer-controlled spacecraft sent to explore space. And a telescope is something that makes things that are far away look bigger. These words will help us as we read this book, and when we come across them, now we'll know what they mean. The Earth is a planet. It's a huge, round lump of rock floating in space. The Earth is one of 8 planets that travel around the sun. The sun and the planets are called the solar system. This is what the Earth looks like from space. The planets in the solar system move around the sun. On this page, you can see the order of our solar system's planets. Pieces of rock called asteroids travel around the sun too. The planets are shown close together on these pages. Really, they are very, very far apart. As well as planets, there are lots of other things that move around the sun, from specks of dust to dwarf planets, such as Pluto. Scientists think that the solar system formed millions and millions of years ago. It began as a huge cloud of gas and dust in space, like this one. The swirling cloud of gas and dust slowly got thicker and thicker. Part of the cloud heated up, making a hot ball of gas. This became the sun. Over millions of years, the gas and dust spun around the sun. Gradually, the dust and gas joined together to make the planets. The sun is a massive ball of burning gas called a star. It gives the planets all their light and heat. The sun looks so big because it is closer to the Earth than other stars. This is what its surface looks like close up. Jets of hot gas shoot out and fall back in long loops. Some parts of the sun are not as hot as the rest. These are called sunspots. Huge explosions are known as solar flares. Never look directly at the sun. Its light is so strong, it could damage your eyes. Each planet travels along its own path or orbit around the sun. They take different lengths of time to move all of the way around. Earth takes 365 days and nights to orbit the sun. This is 1 year. As the planets travel, they also spin around. When each planet spins, different parts have day or night. Light from the sun only shines on one side of the Earth at any time. This part is dark because the sun's light cannot reach it. This is night. The parts facing the sun are lit up. This is the planet's day. Mercury is the planet closest to the sun. Its rocky surface is covered in holes called craters. Most of these were made by rocks crashing into the planet from space. Fast-moving rocks hit Mercury's surface, making deep holes. Lots of pieces of rock and dust flew up around the holes. The rock and dust settled in thick layers around the craters. In this photo, you can see lots of round craters on Mercury's surface. The surface of Mercury is more than 4 times hotter than boiling water. Venus is the hottest planet in the solar system. It is so hot because it's covered in a thick layer of clouds. This is the surface of Venus. The thick clouds make the sky look orange. The surface of the planet is hard rock. The sun's rays pass through the clouds and the planet's surface warms up. The clouds stop the heat from escaping, so the planet gets hotter and hotter. Venus is so hot, its surface glows in the dark. The Earth is made of rock and is surrounded by water and gases. It is the only planet where life is known to exist. The Earth has the right mixture of air, heat, and water for things to live. A layer of gases around the Earth gives living things the air they need to breathe. In this photo, you can see the big lakes and high rocky mountains on Earth's surface. The sun warms the planet. Plants grow in sunlight, making food for animals. More than half of the Earth is covered in water. Everything needs water to live. The moon is a big, round lump of rock that moves around the Earth. It is the brightest thing you can see in the night sky. There are millions of craters on the moon. In this photo, the biggest craters look like dark patches. As the moon moves, the sun lights up different parts of its surface. This is why the moon seems to change its shape. When the side facing Earth is lit up, you can see the moon as a bright circle. Sometimes you can only see part of the side that is lit by the sun. When the sun shines behind the moon, you can't see the bright side, so it looks dark. In 1969, astronauts landed on the moon in a spacecraft. Mars is a cold and rocky planet. Its surface is covered in red dust. Scientists have sent vehicles called Rovers to Mars to take photos of the surface. A rover was packed inside a spacecraft and flown from Earth to Mars. Airbags protected the spacecraft as it landed on the planet's surface. The spacecraft opened up, and scientists sent signals to drive the rover out. The rover drove around, sending information back to scientists on Earth. This is a photo of Mars' surface taken by a rover. Jupiter is the biggest planet in the solar system. It is a huge round mass made mostly from gases. The stripes you can see here are bands of different gases. Jupiter has over 60 moons moving around it. All the moons are made of rock and ice. Phoebe is not round like most moons. Its surface is covered in huge craters. The rocky surface of Europa is completely covered in a layer of ice. Ganymede is the biggest moon in the solar system. It is bigger than Mercury. There is a huge storm on Jupiter that has been raging for thousands of years. Saturn is a huge planet made mostly of gases. It has millions of pieces of rock and ice moving around it. From far away, these look like solid rings. This photo was taken from a spacecraft that scientists sent to fly around Saturn. In 1997, a rocket took off from Earth. It was controlled by computers. When the rocket was far above the Earth, a probe flew away from it. The probe reached Saturn and started to fly around the planet. It sent close-up pictures of Saturn and its rings back to Earth. Uranus and Neptune are huge gas planets. This is Uranus. It has faint rings around it made from millions of specks of dust. Uranus spins differently from the other planets. It looks as if it has been knocked on its side. Neptune is a very cold and stormy planet. This dark blue swirl is a storm raging on the planet. Beyond Neptune, there is a dwarf planet called Pluto. Experts used to think it was a planet, but they've changed their minds. Scientists find out about the solar system by using huge telescopes that let them see things that are very far away. The telescopes shown here are in Hawaii, USA. They use big, curved mirrors to make things that are very far away look a lot bigger. There are some telescopes that travel around the Earth in space. Scientists on Earth send signals to point the telescope at the planet. The telescope takes pictures of the planet and stores them in a computer. The computer sends the pictures as signals to huge radio dishes on Earth. The information is sent to computers that turn them into pictures of the planet. If you think space is really exciting and can't wait to learn more, on page 31 you'll find a website which will give you some links to some safe websites you can find out more about the solar system. These are called quick links, and you can see them at any time. That was so much fun. Now that we've learned about our solar system, let's explore the wonders and dangers of outer space. Let's start by reading about launching into space. For the past 70 years or so, vehicles have been flying into space. the vast airless region beyond our planet and its atmosphere. Most spacecraft are launched into space using a type of rocket known as a launch vehicle. On this page, you can see many details. Information about a booster rocket, the ATV spacecraft. There's also some features about the Automatic Transfer Vehicle, or an ATV spacecraft. These were developed in Europe and have been used since 2008. The purpose is to carry supplies into space with no crew. The launch vehicle is named Ariane V, which is shown here. Did you know that over 500 people from nearly 40 countries have flown into space? So why would anyone want to go into space? Well, because it's there. Humans love to explore the unknown, whether it's a high mountain or an alien planet. But each journey into space or space mission is just an opportunity to make scientific and technological discoveries. On this page, we see where is outer space? Where does it begin? There's a layer of gas around our planet called the atmosphere. It gets thinner and thinner, fading into nothing. That's where outer space, or space, begins. Outer space is full of dangers. There's no air to breathe, there is lots of killer radiation, and there are extreme temperatures. Astronauts floating unprotected in the space would die very quickly, so they need spacesuits and other equipment to keep them alive and safe. You can see this page folds out to show us the entire solar system. Earth is one of 8 planets circling around or orbiting the Sun. The Sun and all the objects that orbit around it make up the solar system. Did you know humans haven't visited any other planets? Astronauts have only flown as far as Earth's own moon so far. Have you ever watched a liftoff? Before a launch, there's usually a countdown lasting several hours, so safety checks can be performed. Just before 0, mighty rocket engines fire, and we have liftoff. During a launch, a series of rocket engines fires. Each engine, or cluster of engines, is known as a stage. During countdown, time is counted backwards from launch. So T minus 2 hours means 2 hours before launch. After launch, time is measured as T plus time passed since launch. This is a Soyuz, a type of Russian spacecraft used to ferry people to and from Earth's orbit. It has 3 main sections, known as modules. Soyuz spacecraft have been used since the late 1960s. This is a 2010 model. The word Soyuz means union in Russian. The name reflects the fact that it's designed to connect with other spacecraft. During launch of a Soyuz spacecraft, the crew sits in the cramped descent module. This diagram shows inside the descent module. We see a hatch, a video camera, a periscope, shock-absorbing seats, where the passenger sits, where the crew commander sits, the flight engineer, the engines, a parachute hatch, a window, and the control panel. This picture is of NASA mission control during a space shuttle mission to the International Space Station. Orders on a NASA mission come from Mission Control Center, or MCC, in Houston, Texas. Most staff members are in charge of a specific aspect of the mission. You can see the seating chart here and what's on the screens. The International Space Station, or ISS, is a vast spacecraft in orbit around Earth. Crew members do scientific experiments there, making use of the unique conditions of outer space. This photo was taken in 2011 by an astronaut leaving the ISS aboard a Soyuz. In orbit, everything floats as though it's weightless. This is known as a zero-G environment. Every surface can be used to mount equipment and store supplies, since the floating crew can reach the ceiling as easily as the floor. Scientists use the zero-G environment of the ISS to do experiments that aren't possible on Earth. Many of these will help future astronauts to travel further into space. This scientist on the ISS is studying plant growth in zero-G. Learning how to grow food in space will be essential when humans travel to other planets. ISS scientists use floating robots called spheres to test new ways of flying spacecraft before test flying full-size craft. Each one of these spheres robots is roughly the size of a soccer ball. When astronauts leave the ISS to go outside, they have to wear special spacesuits. Each suit is like a mini spacecraft that that keeps its wearer alive and safe in the harsh, airless conditions of space. This is a NASA spacesuit known as an EMU, or an extravehicular mobility unit. The ISS crew use a team of robots to help them perform repairs, construction, and other handy tasks outside the station. These robots can be programmed to do anything from fixing external cameras to helping spacecraft to dock by catching them. One robot on board the ISS is more human-like than the others, Robonaut 2. It was delivered to the station in February 2011 and is being tested in a lab on board. Robonaut's touch-sensitive hands means it can adjust its grip like a human and do jobs that Dexter can't. After a spacecraft leaves the ISS, it fires its engines to take it down out of orbit. This is known as a deorbit burn. Earth's gravity then pulls the spacecraft down through the atmosphere at thousands of miles an hour. This is known as re-entry, and it generates incredible heat. These photographers are crowding around a Soyuz descent module after a successful landing. When a Soyuz craft returns home, the crew sits inside the descent module. Heat shields protect them during re-entry, but the other modules are unshielded and burn up. Here you can see the stages of a typical Soyuz landing. Robotic craft known as space probes explore space, carrying cameras and other instruments. They use radio signals to send back data about other planets to Earth. Some probes fly in orbit around planets. These are called orbital flights. Others fly past planets, known as a flyby. Two types of robots have landed on Mars: landers and rovers. Landers take images and do experiments without moving. Rovers roll around on wheels so they can study a wider area. This image of the surface of Mars was taken by Opportunity, one of two identical rover robots. Sojourner was the first Mars rover. It flew to Mars along with our lander. The latest rover, nicknamed Curiosity, is the size of a small car and is the most advanced robot rover yet. It was launched in November 2011. Warning: landing on Mars is very tricky, and landings often fail. Curiosity's landing method had never been tried before too, so the landing was nicknamed 7 Minutes of Terror. But Curiosity made a perfect landing and is now at work on Mars. This is an artist's impression of Curiosity just before landing on the surface of Mars. Curiosity's mission is to look for water and signs of life on Mars. The robot has multiple tools built into it to help it on its search. This is an artist's impression of Curiosity at work on the surface of Mars. The laser beam is drawn in red, but it would actually be invisible. Curiosity is programmed from Earth. Each day's journey is planned out, and then the instructions are beamed to it through space. The first astronauts were animals, sent up to test how living things would react to the extreme conditions of space travel. Flies were sent up first, then mammals such as mice, monkeys, and dogs. In April 1961, Russian cosmonaut Yuri Gagarin became the first human being to fly into space. His spacecraft was called Vostok 1. Gagarin in his flight suit and in his safety harness can be seen here. Scientists were worried that a human might panic in space, so Vostok 1's controls were locked and the spacecraft was guided from Earth. During the 1960s and 1970s, NASA launched a series of missions called Apollo. Their goal? To land on the moon. After some failures and test runs, 3 American astronauts blasted off in Apollo 11 on July 16, 1969. They were about to make history. These foldouts show us the entire length of the Apollo rocket. After its launch, each stage of the Apollo 11's Saturn V launch vehicle fired, then dropped off. About 3 hours into the journey, the command and service module flipped around and connected nose to nose with the lunar module for the rest of the 3-day trip to the moon. It took 3 days to reach the moon, then another day to orbit and prepare for landing. We've all heard the term, one small step for man. On July 20th, 1969, once in orbit around the moon, Eagle separated from Columbia to perform the riskiest part of the mission so far, landing. In the Columbia was crew Michael Collins, and in the Eagle was crew Neil Armstrong and Buzz Aldrin. You can see here that eventually the men made it safely onto the surface. millions of people watched Armstrong take his first bouncing steps on the moon. That's when we hear, "That's one small step for man, one giant leap for mankind." Armstrong and Aldrin spent 2.5 hours on the moon's surface. As well as setting up mechanical experiments and photographing their strange surroundings, they gathered about 21 kilograms or 46 pounds of rocks and dust for scientists to study back on Earth. Buzz Aldrin is shown here checking out an experiment. About 10 years after the moon landings, NASA introduced a new type of craft, the Space Shuttle. Shuttles were launched using rockets, but landed like planes on runways. Here we see Space Shuttle Discovery is being moved into position before launch. NASA's space shuttles ferried astronauts and cargo to and from orbit. There were 6 in total, but one was only used for test flights. Now that you've learned to navigate the mysteries of outer space, let's take a look at our next book. This is See Inside Space Stations and Other Spacecraft. What's out in space? Here, you can see how things change as you travel up away from Earth. It's not to scale, because some of the distances would be too big to show. So what is a space station? All machines that travel through space are known as spacecraft. The biggest, called space stations, are built for living in space. Under this flap, we look at early space rocket test in 1950. This particular rocket, Bumper 2, reached a record-breaking 400 kilometers or 250 miles before falling back to Earth. Rockets burn huge amounts of high-energy fuel very fast, generating enormous thrust. During the 1950s and 60s, the Soviet Union, now Russia, and the USA vied to be the first to launch a craft into space in what became known as the space race. In late 1957, a rocket blasted off from the Soviet Union, carrying an uncrewed satellite known as Sputnik 1. Once in space, the rocket fell away, leaving Sputnik 1 circling the Earth in a regular path or orbit, the first spacecraft ever to do so. The first spacecraft to land on the moon was an uncrewed Soviet probe, Lunar 2, in 1959. 10 years later, the US launched the Apollo 11 spacecraft, which took 3 astronauts to the moon and back. The astronauts sat in a small command module with a lunar module below. A huge 3-stage rocket blasted everything into space. It took 3.5 days to reach the moon, another day to prepare and land the lunar module. A space station is a huge spacecraft with room to live on board. It's designed to stay in space while smaller spacecraft ferry people and cargo back and forth. The Soviet Union launched the first ever space station, Salyut 1, in 1971. It was launched in one piece and destroyed once its supplies were used up. The Americans launched their own space station, Skylab, in 1973. It had a huge telescope and room for 3 astronauts to live and work. The International Space Station, or ISS, is the biggest spacecraft to date. It covers an area roughly the size of a football field and has more livable space than a 6-bedroom house. We can see here these crew members are doing a spacewalk to fix a leaky pipe. Thick spacesuit gloves make the work especially tricky. It's like wearing oven gloves to repair a watch. Because the ISS is so big, it had to be built in bits. The livable parts of the ISS include 15 separate modules. It took 2 years and 4 missions before the station was ready for its first crew. You can see here that even up until 2015, more modules have been added. As one of the closest planets to Earth, Mars has been the target of many research missions. Small vehicles known as rovers have explored its surface. Now, plans for crewed missions are being developed. The surface of Mars is very bumpy, so landing safely was a challenge. Opportunity came down inside a huge airbag. It bounced 26 times before stopping. Then the airbag deflated and the rover rolled out. Curiosity's laser zaps a rock, and the type of sparks reveals what it is made of. For big space stations, built up from modules, astronauts need to be trained how to put the modules together in space. Some training is done in machines, and some underwater. Floating underwater is similar to floating in space, and also requires breathing equipment. This huge pool in Star City, Russia, was built for testing equipment and training astronauts, known as cosmonauts in Russia. The pool was used to train the astronauts and cosmonauts who assembled the International Space Station. The pool is as deep as a 4-floor building. This is a life-size mock-up of a space station module. Distances in space are so vast that most space travel has focused on our nearest moons and planets, but a few spacecraft have ventured beyond the solar system into deep space. Voyager 1. An exploratory spacecraft or probe named Voyager 1 launched in 1977 to explore the outer reaches of the solar system. Voyager 1 finally left the solar system in 2012. In case the probe is found by aliens, it carries a gold disc with recordings of nature sounds, music, and greetings in 50 languages. The disc is engraved with pictures giving more information about the Earth. The next star is so far away, Voyager 1 will take about 80,000 years to reach it. Even if you could travel at the speed of light, much faster than any spacecraft ever built, it would take over 4 years. New ideas and inventions mean future space travel could be quite different from today. Some companies are building reusable rockets. Others are developing space planes to let more people experience space. One challenge is to find ways to power spaceflight on long trips. One of the biggest problems is the huge amount of fuel it takes to get off the Earth. Scientists hope to develop tiny nanocraft with solar sails and then use lasers to blast them to incredible speeds. If it works, a nanocraft could reach our next star, Alpha Centauri, in 20 years.
Thanks for joining me today. I know I had a blast. Reading is so much fun together, and I really hope you join me for some more great books. In the meantime, check out my YouTube, Facebook, and Instagram for my favorite books. Thanks for joining Amanda's Reading Corner, and we'll see you next time.